All right, welcome to this explainer. Today, we are going to totally demystify data warehousing. It's a core skill for any data engineer, and we'll be using a case study from a fictional food delivery company called Hungry Now. This is going to make all these concepts super practical and clear, especially if you're working on your apprenticeship.
Okay, let's kick things off with a really simple analogy. Imagine the system that takes all the customer orders. It's like a crazy busy, chaotic restaurant kitchen. I mean, it's fantastic for getting orders out the door fast, but if you try to analyze anything in there, it's a total mess. Our goal is to build an organized pantry, our data warehouse, where every single ingredient is cleaned, perfectly labeled, and all set up ready for you to cook up some amazing reports and insights.
So first things first, let's step right into that messy kitchen and really get a feel for the exact problem we're trying to solve at Hungry Now.
So here's the challenge. Hungry Now's data is literally all over the place. You've got order info in a Postgres database, restaurant details sitting in MongoDB, app logs are just dumped into S3, and you have driver locations streaming in as real-time GPS data. So trying to answer what seems like a simple question, like, hey, what's our average delivery time in Manchester? Well, it becomes this huge, messy job of stitching everything together. It's slow, it's difficult, and it's just not efficient.
And this is where we come in. The solution, our master plan, is to build that data pantry, the data warehouse. It's going to act as our central, structured, and perfectly organized source of truth.
But what is a data warehouse, really? I mean, what makes it so different from the databases we already have? What's its specific job?
Well, a data warehouse is a system that's designed for one main job, and one job only: analytics. It pulls data from all those different messy sources, cleans it all up, and structures it in a way that is just perfect for read-heavy queries. So we're talking about things like business intelligence dashboards and complex analytical reports, not for processing day-to-day transactions. Okay, so let's get practical. What tools would you actually use for this? This slide lays out a pretty typical tech stack an apprentice might work with. We'd start by just ingesting all that raw data into a data lake, something like Azure Blob Storage. Then we use an ETL tool. ETL stands for Extract, Transform, and Load, like Azure Data Factory, to clean it up and load it into our warehouse, which might be Azure Synapse or Snowflake. And finally, tools like Power BI or Tableau connect right to that warehouse to create those awesome, valuable dashboards.
Right. Now let's talk about how we actually organize the shelves in our data pantry. The most common and, honestly, most effective design you'll see is called the star schema.
And it gets its name because, well, it kind of looks like a star. Right in the middle, you have what's called a fact table. This holds all the core numbers for the business, the what happened. And then radiating out from the center, you have these dimension tables, which give you all the context, the who, what, where, and when.
So for our company Hungry Now, you can see our central facts table, fact orders, sitting right there in the middle. It's holding key metrics like the order value and the delivery time. Then, branching off that, we have our dimension tables, which add all that rich context. Dim Customer tells us who ordered. Dim Restaurant tells us where the food came from, and so on for the driver and the date.
And here is where that beautiful structure really pays off. Just look at this simple SQL query. By joining our main fact orders table with a couple of dimension tables, we can instantly answer a pretty complex question like, what's the average delivery time by city for each hour of the day? It's this ability to easily slice and dice our core facts by different dimensions that makes the star schema so incredibly powerful for analysis.
Now, while the star schema is the main one, it does have a cousin called the Snowflake schema. Snowflake can save you some storage space because it breaks down those dimension tables even further. For example, your restaurant dimension might get split into separate tables for city and cuisine. The trade-off? Well, it adds more complexity and can actually make your queries slower because of all the extra joins you have to do.
Okay, so let's zoom out a bit. How does our data pantry fit into the wider data world? Because it doesn't exist in a vacuum, right? It works alongside other really important concepts like data lakes and data marts.
So what's the big difference between a data lake and our data warehouse? Think of the data lake as this giant bulk storage area at the back of the pantry. It holds all the raw, unfiltered ingredients, things like app logs, images, messy JSON files in their original format. It's cheap, it's flexible, and it's perfect for feeding machine learning models. The warehouse, on the other hand, holds the pre-prepped structured ingredients, all ready to go for business reporting.
Now, sometimes giving someone access to the entire pantry is just too much. For that,
we can create data marts. A data mart is simply a smaller, focused view of the main data warehouse designed for a specific team, like marketing or finance. It's basically like creating a little curated spice rack just for them.
So at Hungry Now, the marketing team could get a data mart that's all about customer acquisition and campaign performance. The operations team gets one focused purely on delivery times, and the finance team gets their own for revenue and costs. This keeps everything clean, secure, and it means each team gets exactly the data they need, and they get it fast.
So here's the crucial takeaway. All this technical work, it's not just about shuffling data around. It's about turning that data into actual decisions. And more importantly, it's about being able to clearly explain the value you've delivered, which is absolutely vital for your portfolio.
But before you build, just a heads up on a few common traps. First, do not try to run heavy analytics on your day-to-day operational database, the one that runs the app. It's not built for that, and you will grind it to a halt. Also, don't overcomplicate your schema for reporting. And please, whatever you do, don't let your data lake become a dreaded data swamp without proper governance and documentation.
Okay, let's put this all into practice. This slide shows you how to translate your hard work into these really powerful I statements for your portfolio. So instead of just saying you know what a star schema is, you say, I built a star schema data warehouse that enabled stakeholders to query KPIs. See the difference? It connects your actions directly to business outcomes.
And if you want to really stand out, maybe aim for that distinction, you need to explain the why behind your choices. Talk about the trade-offs you considered, like choosing Star over Snowflake. Mention how you integrated different systems, like using a data lake for machine learning and a warehouse for BI. You can even show you've thought about advanced topics, like how you would implement security to protect sensitive data.
So there you have it. You now have the blueprint for turning total data chaos into crystal clarity. You can go out and build that perfectly organized data pantry. So the only question left is, once it's all built and all that powerful data is right at your fingertips, what's the first question you're going to ask?